Good afternoon, everyone. I'm Mariana.
And I'm Daniela.
And together we have developed our final degree project, which is called Second Round, Design from the Existent. Before we begin, as you can see, we have left you a little booklet, which is the white one you have there, which will function as a guide during the presentation. You can start opening it if you want, and there you can see the blocks that we are going to read during the presentation. We have also left you a little gift, which is this thing, which refers to the bookmark. It's a bookmark that we use to mark the glossary in our museum. So, you look like ready? Are you ready? So, Dani, let's get started, please. We don't see things until someone points them out. This idea was the starting point of our project. During our career, our degree, we realized that product design teaches us to look forward toward the new idea, toward the new solution, toward the object that doesn't exist yet. But we are rarely taught to look with the same intention at forgotten, obsolete, unused objects, at what already exists. With that, one main question appeared. What would happen if product design didn't start from zero? This question isn't only about reuse or sustainability. It also opens a methodological gap. If design can start from what already exists, then we need to check if this way of designing can be organized, explained, and transferred. For this reason, our project was structured around two hypotheses. The first one states that contemporary product design doesn't have a sufficiently clear methodology to understand the existing object as an operational starting point. And the second one states that this absence can be solved by creating a methodological pattern built from the analysis of cases, the classification of recurrent operations, and its translation into a data. Therefore, our main objective was to check if this way of designing, design from the existent, can work as a methodology.
At the beginning of the research, we saw that all this work couldn't appear out of nowhere. Projects by 5.5 Studio, Drug Design, Martino Gamper, Maquia Tu Vida, Curro Claret, or Insomari shows that it's possible to create new readings, users, or meanings from objects that have already been produced. So the problem wasn't that nobody was working with the existing before. The problem was something else. Most of the practices appear as isolated cases, not as a clear methodology that we can easily understand or learn it, or that we could repeat it. So we identified the main gap of the project. We didn't want to create from zero. We want to design from the existing to be organized. We want with creation from the zero, we want to organize all the research that we did before and turn it into an operational structure. The structure that we decided to use was research through design, which means working both with theory and practices. Once we understand that, we are divided into six parts: researching reference, analyzing cases, systematizing patterns, prototyping a first guide, validated the workshops, and reformulated until reaching a final manual. To start, we collected more than 300 cases to turn it into the atlas. Then we looked at 16 cases in deep, and to finish, we validated through workshops which result in 22 final cases.
While we were comparing the cases, we started to realize that some of the interventions were repeated. Like, for example, some objects were combined with others recycled a piece, others reconfigured its parts, etc. That's when we stop to talk about isolated cases and start to talk about operations, which is like the main event of our project, and that is going to tell us more about it.
Operations are the what to do. How can we intervene into the existing objects? We divide the operation in 7 parts: repetition, addition, utilization, reconfiguration, external activation, recontextualization, and metacondition. For example, when a new piece is added to complete or adapt an object, we call it addition. Or when we change the context from an object without changing the material, we call it recontextualization.
But operations weren't enough. We were also missing the how to do it. That's why we have decided to add another layer, the principles, which we also decided to divide in 2 groups. The operational principles, which have to be with the way of interviewing the object, like, for example, keeping the intervention visible, or the KISS principle, which means keep it simple, stupid. Alvaro already knows that. And the conceptual principles, which have to be with our attitude during the interventions. Like, for example, using play or irony as a tool, or using visual poetry as a tool. So, now that you kind of know something about the system, and before passing on to the blog 4, which is the manuals and the workshops, we are going to do a little test with you. On your booklets, right in the middle, you will
the white ones.
The white ones. Right there, it's a little test section. You may be asking, why are we doing it? That's because during the evaluation of the first workshop, we decided to do a similar game to know the students understand the system. So, pay attention, because you all are going to compete. You will, it's only 3 questions, you will have to answer the question and raise your hand fastly, because the faster question will obtain more points. You will have to point your punctuation. The first one 3 points, the second one 2 points, and the last one 1 point. If you didn't answer the question, 0 points. You're going to compete. So the highest score will obtain this very precious piece of chocolate as a prize. So, are you ready? Okay, Lani, let's start.
So, when we have a broken share and we add a prosthesis, what operations is this?
Addition. We will see. Okay, you have accurate.
Reconfiguration.
Yeah. Addition. So Lola was the first one.
Okay.
So she wins 3 points.
3 points. 2 points for you. 2 points for
1 for you, Alvaro.
No, 0.
Go faster.
Santo. That you said.
¿Y el refuerzo positivo?
Ahorita no. So next question. If we have a lamp and we multiply it 1,000 times to have a new object, which operation is this?
Repetition.
Okay. Did you answer it well?
Álvaro, 0 puntos.
One point for you. That's enough. And Lola, 2 points for you. Right now, you both are with the same punctuation. And Alvaro, you can keep trying.
So, last question. Play as a design tool, visual poetry. What type of principle are these?
Yeah. Yes. So, Lola, you are the winner because you obtained the highest score. But we have all learned and we have all had fun in your positivo. You have to Jose and Álvaro because if everybody learns, everybody wins. So then, let's move on to the next block, which is the manual.
Once the system of the operations and the principle was defined, we translated to the first tool, the manual alpha, which is the red one you have on the table. This manual works as a prototype to help us check if the system could be understood and applied. We tested this first one with a workshop with 10 participants, 5 students and 5 graduated designers. In terms of results, the workshop validates that the system works, which is a great sign. But we have some areas of improvement. The text density was too long, the visual heritage, and the steps need to be more clear. In conclusion, we need a manual more autonomous, more visual, and more easy to consult. Here, the main changes appear. We decided to divide the system into 3 volumes. We simplify the operations and the principles, and we add the intervention strategies, the iconographic system, and the creation of the atlas as a visual tool. In conclusion, we passed from having a experimental and analytic manual to a more clear and operational and more easy to consult one.
It doesn't matter. So these changes lead to the manual beta, which is the final system of our project. Danny is going to pass the volumes to you so you can see it. And as you can see, the first manual contains the operations and strategies.
That's the first manual. The
second manual contains the principles, and the third manual, the manual from Álvaro, contains the atlas that works as a visual repository to identify operations and to learning from operation. You can them if you want. We will wait if it's necessary.
Álvaro, if you see like this.
Then also we have Okay, so when you are ready, we can continue the presentation, obviously. Okay, Annie, tell us.
After reformulating the manual, we carry on the second workshop. In this case, the variables were more limited. The objects were selected before, the materials were limited, and the manual was used completely autonomy. The results were positive. We reached 95.4% of perceptive effectiveness.
Yay!
And the 100% of the participants understand the concept, apply at least one operation, and connected the proposal with one principle. And they also tell us that they could repeat the process with another object. Autonomy reached the 85.3%, which is the lowest value that we have. But it's interesting because compared to the first workshop, it was a better record. And it happens with less external support. From a critical point of view, we can consider that the project creation from the existing can be structured as a methodology within project design. The operations organize different ways of intervening, principles, criteria, and intentions, and the manual allows the system to be transferred to other people. However, this validation must be understood as a limit. We cannot say that the system has been universally validated and it wouldn't work in all the contexts with any professional profile. The samples belong to a specific education context, and autonomy is still the main area of improvement.
Okay, so at the beginning, we said that we don't see things until someone points them out. And during the presentation, we have this little character, which is Samu. That's so cute. This little character here that has been here all the time, but you didn't really notice it until we pointed it. But now you can stop singing. And second round, functions in a reasonable way. As a response to major problems such as overproduction or the cultural replacement, it points a new perspective for product design, designing from the existing as operational starting point. So we hope that now that we have pointed out this point of view, it can be part of how we all think about product design. Thank you all for listening, and if you have any questions, please feel free to ask.
Okay. Good afternoon, my name is Tomás Arriete, and today I'm going to present my final degree project, Improvement of the Nesting Process for 2D CNC Cutting, a comparison of manual, algorithmic, and hybrid methods. This research focused in the bidimensional CNC routing process applied to board former materials. In this process, the CNC machine transforms a digital file into a physical cutting operation. However, before the machine starts cutting, there is a planning stage that strongly affects the final result. This is where nesting appears. In this project, nesting means placing, is the process of placing parts on a limited board area. This is an example of what is a nesting view. Nesting happened before machining, but its impact affects the whole production process. The way parts are placed after material use, preparation time, workflow, and the final production result. So nesting is not just a previous step, it's a production decision. At first sight, nesting may look like a simple task, placing parts inside a board and trying to use as much place as possible. However, in this research, nesting is understood as a broader process. Includes geometry, technical limits, and production decisions. You can see a graphic about the nesting process, that is preparation, the nesting process, machining, and the final result of the workflow. Nesting is not only about reducing waste in materials, it's the preparation time, the number of parts placed, the leftover material use, the layout quality, and the dependence on the technical judgment. The main concept for that reason is that nesting should be understood as a logical of production decision. A good nesting solution must balance material use, time, technical limits, and production logic. From this idea, the main research questions appear. If nesting depends on several variables, which method solves nesting more efficiently? This question leads to the comparison between three different methods. Traditionally, nesting has been solved manually. It is also related to cutting and packing problems, where different parts must be placed inside a limited material area while respecting geometry relations. This logic also appears in terms of packaging, logistics, meridian, order of different types of containers, and industrial production. Today, nesting has changed because of the digital and algorithmic tools. These tools can process part geometry and create nesting layout automatically when the technical parameters are correctly defined. The software can calculate faster, but the results still need to be understood from a production view. The project compared three different methods. The manual, that is based on an AutoCAD organization, it depends on the visual judgment and the technical experience of the operator. The algorithms was done with NestandCAD, a software that makes algorithmic nestings. In this case, the software creates the layout automatically, and the hybrid methods that combines both. The main objective was to analyze which method offered the best balance between material use, preparation time, and production feasibility. The principal hypothesis is that algorithmic operation software improves nesting efficiency and compared to manual nesting. And we have some specific hypotheses, and I'm going to remark two of them. That is that the irregular geometries or internal voids create leftover material that is difficult to use, and the waste along do not reflect overall efficiency. And speaking a little bit of the objectives, the main objective is to analyze the nesting efficiently by comparing the manual, algorithmic, and hybrid methods, and some different specific objectives that I'm going to remark on. That is the first, the third, and the fourth. They identify the technical contents that shape nesting, analyze decision criteria in organization the nesting, study the geometry, and measure time, waste, and place part in each method. And speaking of the experimental method, we put 8 different instances divided in 3 methods each. Each instance represents a different situation and depending on the size or geometry of each part. The same set of parts was solved with 3 different methods. All tests were done under the same condition, a board of measure of 3000 by 1500, giving a margin of 20 millimeters from the main board and a space between parts of 8 millimeters. We have some samples here. If we want to look at different colors. The boards are made from the cutting process. And continue with the height scoring matrix. The research analyzed quantitative and qualitative variables, the one that you can see here, and we have like the 100% of the matrix. 70% are the quantitatives, and the 30% are the qualitatives that are in the dog list there. Jumping to the development of the project, we divide it in 4 patterns that appears in the investigation. The first one is based on the mixed aspects. In this case, nesting become more complex because large and medium and small parts must coexist in a same board. The one that you have there are small parts. You can compare the size. So in this case, nesting become more complex because a large part strongly affect the layout. As you can see there, they're the big ones. The monkey there are the big ones too. The monkey face are the medium, and the small, the little dots there. So a large part strongly affect the layout, and the medium and small part can help filling the empty spaces, but only if the layout is well planned. That shows that the size vibration increases the complexity. The second pattern appears in the simple and repetitive geometries. In this case, the difference between methods were reduced or even disappeared, as in this case. This means that the geometry is modular and predictable. The method has less influence on the result. Software does not have same impact in every situation. Geometry can reduce or increase the geometry can reduce or increase the difference between methods. The third pattern, and one of the most important of the process, are the organic parts that are harder to organize because they don't have a straight edge or predictable shape. This creates irregular gaps and leftover materials in this difficult to reduce. In this case, the algorithmic and hybrid method achieves better results. As you can see here, they are the same, and the manual have lower qualifications. The conclusion about this problem is that non-rectilinear geometry complicates the comparison. So the final pattern is one, as the one I said Before is one of the most important cases that this instance with internal, combined, medium, and small parts. This case shows that the layout can look visually full, but is still inefficient. We can see here the weight percent, and compared with the other ones, that the percentage are quite similar, but if we compare with the first one, are a little bit lower. So, to conclude this development, the general results show that clean trends. The algorithmic method obtains the best result, followed by the hybrids, and the last point was the manual ones. Each method shows a different behavior. The manual methods are flexible but variable. The algorithmic method was fast and compact, and the hybrid method was useful but not always better as the algorithmic ones. The 5 hypotheses was confirmed. The more important now as a conclusion is the first one, the third one, and the fourth one. And based on the 5 objectives that are met, as I said in the beginning, the first, the third, and the fourth was the most important ones. As a critical evaluation, automation improves the nesting process, but it does not eliminate the value of the operator. The change is the operator role. In a manual process, the operator creates the solution from zero. In an algorithmic or hybrid, the operator has more strategic role, validates the result, interprets the layout, and decides if it makes sense on production. So the future of this process should not be seen as a software against human judgment. It should be seen as a better decision of task. The project also opens future research as more operators from each instance. The real cutting process, following with the cutting phase, the damage that the different phrases have, the economic analysis, the CAD/CAM and RPM, and the leftover material management. And to conclude, the improving nesting does not depend only on placing more parts or reducing waste. Real efficiencies appear when several variables are balanced. In the test condition, the algorithmic method was the most efficient because it reduced time and generated a stable, compact solution. However, this doesn't mean the human judgment disappears. The final conclusion is that software helps organize the process better. The software calculates, the operator validates, and the production system benefit from both. Thank you very much.